10 years ago, I was working at a software company where I was writing a carousel which was populated from the data in the database. The data was showing fine, however, the formatting was a bit off. I was under immense pressure to demo this feature to the product team. I reached out to my team lead to get his help. Within 10 minutes, the feature was fixed and we could demo the feature, and the product team walked away happy. After the meeting, I decided to check the code written by my team lead, as that would be a learning experience for me. I was surprised to find that he had hard-coded the data in the front end. Something similar is happening right now in the model evaluations world. Let's talk about it. Berkeley has just released an article destroying the credibility of all AI evaluation benchmarks. In an article titled "How We Broke Top AI Evaluation Benchmarks and What Comes Next," they have gamed all the major AI evaluation benchmarks and got perfect scores. For terminal benchmark evaluation, they found that the evaluation task downloaded the Python UV dependency at runtime from the internet. They exploited this little detail to intrude into the system. The agent created by UC Berkeley intercepts these curl requests and intrudes into the UVX binary, and compromised UVX reveals the PyTest invocations and produces fake passing output. As a result, the eval gives 100% score without writing a single line of code. SWE is considered as the most influential AI evaluation benchmark. As per the SWE benchmark, the model is required to address a real-world GitHub issue where the model should produce a patch, make all the failing tests pass to secure the score. Researchers manipulated the test container to force pass all the tests. Without applying a single line of patch, the issue was resolved, as the results of these force pass tests was passed down to the grid. In the instances where the unit test runner is used, for example, for TypeScript and Go, the researchers replaced the unit test runner with a function which unconditionally passes success, thereby skipping the entire test loop and reporting success without writing a single line of code. Arena, Terminal Bench, Car Bench, Fieldwork Arena, and other benches have been gamed in the similar manner. But wait a minute. You might think that researchers here were just testing out the eval frameworks and playing devil's advocate in order to highlight the vulnerabilities in the existing eval frameworks. But nobody in the actual world might have exploited these vulnerabilities, right? Well, you are wrong. Benchmark scores are being manipulated, inflated, or rendered meaningless, not in theory, but in actual practice. GPT-3 and Claude Sonnet 3.7 were found to boost their benchmark scores by over 30%. Researchers have identified 7 deadly patterns across 8 evaluation benchmarks, which need to be fixed if the evaluation benchmarks have to remain relevant. So what are these dangerous patterns? First is that the evaluator and the model being evaluated share the same environment. They share same containers, and hence all the tests are accessible to the model in the runtime. This makes them susceptible to be inferred by the agent and to be used to increase its score. Second, the answers to the tests are being packaged along with the tests themselves. Sometimes the correct answers to the tests are available publicly or are published by the evaluation framework itself on a public platform. These can be accessed by the agent over the internet or by accessing the answers which are in the same container as the model. This is like providing answer sheet to the student who is appearing to the exam. Cheating is only logical. Third, the tests are directly running the code generated by the model, making them vulnerable to other security risks in addition to corruption of score. Number 4. Tests that use LLM as a judge will always be susceptible to prompt injection. Number 5. Strict string matching. Personally, I do not feel that this is a problem. Output of an LLM will always be probabilistic. Expecting strict string matching from an LLM output would defeat the point of using LLMs altogether. Number 6. Some of the evaluation test logic is outright broken. This needs to be bug fixed. Number 7. Most of the evaluation frameworks trust the output provided by the test engine or the reward files which are not written by the eval framework itself. This makes it susceptible to incorrect reward files or fudged test results. This becomes even more problematic when the test results and the reward files both are accessible to the models which are being tested by the test evaluation framework. In absence of proper isolation between the models and the test frameworks evaluating them, the evaluation frameworks are completely meaningless. So, what is the solution to all this? Researchers at UC Berkeley are coming up with a evaluation framework audit agent. They are calling it Blackjack and it is under development currently. This agent is supposed to audit the evaluation frameworks which are supposed to evaluate the AI models. Whenever a model developer wants to publish the evaluation scores for their model, they can run the evaluation frameworks once through this audit agent before publishing their score to the public in order to avoid public embarrassment. Having said all of this, all the hope is not lost, as the evaluation frameworks can still identify the shortcomings and gaps in their tests and fix them so that the future evaluations are more trustworthy and credible. Let me know what are your thoughts on the gaps in the model evaluation frameworks in the comment section below, and I'll see you in the next one.